Unit 4A, Lesson 2. In this lesson, we're going to continue factoring quadratic expressions and eventually get to solving equations using the factoring method. In this lesson, we're going to focus on factoring quadratic expressions that have a leading coefficient in front of x squared other than 1. In order to factor a quadratic expression with a leading coefficient other than 1, there's a little pattern that we can follow to help organize the information in the process. So what you should do is create an x. In the top portion, we're going to take the a value times the c value. So the a value is the value in front of x squared. The c value is the constant by itself. In the bottom portion, we're going to put the b value, the coefficient in front of x. F sub 1 stands for our first factor. F sub 2 stands for the second factor. And we'll get to that. These values will make more sense once we go through this problem. So if we were going to start factoring out 2x squared plus 10x plus 12, in my top portion, I'm taking a times c, so 2 times 12, I get 24. In the bottom portion, I'm going to put my factor, or my b value, which is 10. So now I'm going to create my list of factors for 24, and I'm looking for the combination such that when I add those two factors together, I get a sum, well, that should be a 2, a sum of 10. So I have 24 and 1, 12 and 2, we have 8 and 3, and then we have 6 and 4. So we can see at the end, 6 plus 4 is going to get us 10. So those are the two factors I would put on these outside boxes. So in the top portion, take a times c. In the bottom portion, put our b value. We're looking for the factors of 24 that are going to have a sum of 10. In this case, I knew my top number was positive. So either both factors were going to be positive or both were going to be negative. I looked at my b value. My b value was positive, so that's how I determined these factors both had to be positive. Now to the first example, we want to factor 6x squared minus 11x minus 7. In the first box at the top, we have to take a times c, 6 times negative 7, so we get negative 42. In the bottom box, we have our b value, negative 11. So we need to list factors for negative 42. Since this is a negative value, I know one factor has to be negative, one has to be positive, and since my b value is negative, the larger absolute value of those two factors has to be the negative one. Now that we have our list of factors, we want to find the combination that has a sum of negative 11, which would be negative 14 and 3. So now we have to take each of these factors and divide it by our a value. Okay, so first we'll start with the negative 14. We're going to take negative 14 divided by the a value, which is 6, and we want to simplify this fraction. 2 goes into each of these, so this would simplify to negative 7 over 3. So when we're trying to put this in factored form, for my first set of parentheses, the number in the denominator is going to be the coefficient in front of x. So I have a 3x, and the top number is the constant, minus 7. Now we want to do the same thing for our value of 3. We're taking 3 divided by 6. Well, that's a good 6. 3 divided by 6, which would simplify to 1/2. Again, the bottom number is going to be the coefficient in front of x, so we have a 2x, and then plus 1. So this is the factored form for 6x squared minus 11x minus 7. Again, we could use the FOIL pattern to check and make sure our factored form is correct. 3x times 2x would get us 6x squared. 3x times 1 is 3x. Negative 7 times 2x is negative 14x. Negative 14x plus 3x is negative 11x. And then negative 7 times 1, negative 7. Now to the second example, we want to factor 4x squared plus 13x minus 12. We take 4 times negative 12, negative 48. and we want to find the factors that have a sum of 13. So we need to find the factors of negative 48. Again, one of them has to be positive, one of them has to be negative. The larger absolute value of those two factors is going to be the positive one. So we make our list of factors for negative 48. The combination that's going to work is 16 and negative 3. So we take our factor of 16 and divide that by our a value, which is 4. So this will simplify down to 4 over 1, which tells me the coefficient in front of my x term is going to be 1. So I'll have x plus 4 for that first factor. Then I'm going to take my negative 3, divide that by the a value of 4. This fraction does not simplify, so now I know the coefficient in front of this x term is going to be 4. So I have 4x and then minus 3 at the end. So here's our factored form for the original quadratic that was in standard form. We could use the FOIL method to check and make sure that we did the process correctly. Before we get into solving quadratic equations using the factoring method, we need to talk about the zero product property, sometimes referred to as the zero factor property. So this property tells us if we have a times b equal to 0, then either a is equal to 0 or b is equal to 0 or both of them. So if we have two factors being multiplied and that product is equal to 0, well then at least one of those factors, either a or b, must be 0 or both of those factors must be 0. For this next example, we want to solve the quadratic by factoring. So we're going to go through the same process we have been doing, then we're going to use that zero product property to find what those x values actually are. Sometimes they're going to start this equation with y equals the expression, and then they'll want us to find the x-intercepts. If we're looking for the x-intercepts, we're just going to put a 0 in for that y value. We're looking for the x values that make the y value equal to 0. Okay, so the first thing we need to do is identify our a, b, and c values, go through that same process. So 2 times negative 3, we have negative 6, and then our b value is negative 5. So making our list of factors, finding the combination that works. There's not a lot of factors for negative 6. The combination that works is negative 6 and 1. So we take our factor of negative 6, divide that by our a value of 2. This simplifies down to negative 3 over 1. Then we take our factor of 1, divide that by 2, and that one will not simplify any further. So now we want to put this in our factored form. So we have a 1x, or just x, minus 3. And then our other factor is going to be 2x plus 1. Okay, so far it's the same process we've been doing. Now we need to use the zero product property. We have two factors. Our first factor is x minus 3. Our second factor is 2x plus 1. The zero product property tells us that either this factor is going to be equal to 0 or this factor is going to be equal to 0 or both of them, because the product of these two factors is equal to 0. So what we need to do is set each of those factors equal to 0 and solve. So I have x minus 3 equal to 0. To solve this, I would add 3 to the other side, so I get x equals 3. Then I set 2x plus 1 equal to 0. First, I would subtract 1 to the other side, and then divide by 2, so I get x equals negative 1/2. So my two solutions to this quadratic equation, if we're solving it using the factoring method, are x equals 3 and x equals negative 1/2. Now to the last example, we want to solve the quadratic by factoring. We have 0 equals 5x squared minus 8x plus 3. So we take 5 times 3, our top value is 15, and our b value is negative 8. So list of factors for 15 such that we get a sum of negative 8. This time I know both my factors have to be negative. The combination of factors that's going to work in this case is negative 5 and negative 3. So I take negative 5 divided by our a value of 5, which simplifies to negative 1 over 1. And then we take our other factor of negative 3 divided by 5. So now we put those in factored form. So I know I'm going to have an x minus 1 for one of my factors, and then I'm going to have a 5x minus 3 for the other factor. Again, we could use the FOIL method to quickly check and make sure that we factored this correctly. So now we use that zero product property again. We're going to set each of those factors equal to 0 to solve for the x values. So we have x minus 1 equal to 0. So we get an x value of 1. And then we have 5x minus 3 equal to 0. So in this one, first we would add 3 to the other side and then divide by 5. So we get x equals a positive 3/5. So two solutions, x equals 1, x equals 3/5. So we go through this process just to refresh everything. A times c to get our top value, our value of b in the bottom portion, find our factors for our top number that have a sum of the bottom number. These are the two factors we get. We have to take each of those factors divided by the original a value, and then that gets us our combination, our pattern, so that we can put it in our factored form. If we're solving, then we have to use the zero product property to set each of these factors equal to 0.